Hey folks, I'm going to go through some pretty just basic stuff about balancing reactions, and some of this is going to be review. And I'm going to start a timer so I don't blather on too long. This will be no more than 5 minutes. All right, so we've started talking about balancing reactions. And we're going to look at a reaction. Butane, which we use in lighters, is C4H10, and it burns an oxygen to form, just like every hydrocarbon when it burns forms, carbon dioxide and water vapor. So you're being asked to write this. So the way we can read this once it's written is that butane gas and oxygen gas forms carbon dioxide gas and water as a gas. So we're going to look at this reaction right here. Aqueous sodium bromide and chlorine gas form aqueous sodium chloride and liquid bromine. Couple things you need to remember. Don't forget your Hofbrinkels. And what I mean by that, if you look at the back of your periodic table, you've got this written out. In the back, these are all your diatomic atoms. Sorry, molecules. Your diatomic molecules. What I mean by that is chlorine is a Hofbrinkel. It is chlorine. So really the way we would write it is Cl2. And here it's making liquid bromine. Well, bromine is a Hofbrinkel, so we would write it Br2. Same thing with nitrogen. If you're ever told that nitrogen reacts with something, it's N2. Iodine is I2. Fluorine is F2. Oxygen, which we've seen a lot, is O2. And hydrogen is H2. So when you're writing a reaction, you need to include the formulas for all the substances. Formulas meaning like if it's chlorine, it's Cl2. Or if it's water, it's H2O. Or if it's sulfuric acid, it's H2SO4. And you may include states. It doesn't hurt to include them. This is a solid, liquid, gas, aqueous, meaning it's just dissolved. And you should balance the reaction. That's really what we're going to focus on today. And we're not going to include any masses. So if you've got 5 grams of chlorine, you don't put that in the equation. So this is the equation right here that we were asked to write before. I know you guys, we haven't really gone over balancing equations. I'm just giving you some background, don't freak out. So if we were going to write that out, aqueous sodium bromide, well, NaBr, sodium bromide, and we put AQ to show that it's dissolved in water. Chlorine gas, we put G to show that it's a gas. NaCl, sodium chloride, is aqueous, dissolved in water. And then we get liquid bromine. Now we're going to segue into balancing. So this equation we just looked at, if we were going to draw out the molecules, it looks like for bromine here, these are your bromines. Well, what this is saying is that we're reacting this one bromine over here to give us 2 bromines. That makes no sense. You can't just create more of an element. So we need to balance it. And this seems to contradict the law of conservation of mass. But if we add 2 molecules of sodium bromide here with 1 molecule of chlorine gas, 2 molecules of sodium chloride, and 1 molecule of bromine are going to be formed. So by changing what we call these coefficients, make sure you know this, by changing the coefficients is how we balance reactions. If you're going to balance a reaction, you cannot change the subscript. The subscript are these little things down here. Because if we could do that, well, we'd say, oh, there are 2 bromine here. Well, I'm just going to put a 2 here. You can't do that. Remember that sodium's got a +1 charge. Bromine's got a -1 charge, so it's only a 1-to-1 ratio. So this would never have an NaBr2. All right, my 5 minutes is up. Hope this helped.